Hello and welcome to the AI with Arun Show. On January 31st, 2026, Nancy Guthrie, the mother of journalist Savannah Guthrie, disappeared from her home in Tucson, Arizona. In the past, a case like this would rely on fingerprints or footprints. But this investigation was different. It didn't just use police work, it used an algorithmic dragnet. What we are going to look at today is how investigators use the Internet of Things, the sensors in our homes, our medical devices, and our cars, to reconstruct a crime that had no eyewitnesses. We're going to break down how artificial intelligence recovered deleted data, analyzed the suspect's walk, and even measured their eyes through a ski mask. By the end of this, you'll understand why, in 2026, it is almost impossible to disappear without a trace. Let's start with the timeline. In modern forensics, we don't look for a witness. We look for a digital heartbeat. A home today is full of sensors that tell us exactly when things are normal, and exactly when they go wrong. Here is the map of normalcy. At 5:32 p.m., we have Uber logs and GPS data showing Nancy going to dinner. At 9:48 p.m., her garage door sensors confirm she returned home and the door closed. That is our baseline. But then, the heartbeat stops. At 1:47 a.m. on February 1st, the hardwired Nest doorbell was manually disconnected. Now pay attention to this. The suspect didn't just smash it, they disconnected it. This told the AI analysts that the suspect had technical skills and had likely done reconnaissance on the house before the attack. This wasn't a random break-in. It was a targeted digital silence. This is where the investigation gets truly sci-fi. The most critical witness in this case wasn't a person. It was inside the victim's body. Nancy Guthrie had a pacemaker. Modern pacemakers, like those from Medtronic or Abbott, use Bluetooth to handshake or sync with a smartphone app every 3 minutes. It's a digital tether. Nancy's phone was found left behind at the house. But at 2:28 a.m., that Bluetooth handshake failed. Why is this huge? Because Bluetooth has a range of about 30 feet. The moment that signal failed, investigators knew that Nancy had been moved away from her phone. By combining the doorbell disconnect at 1:47 a.m. and the pacemaker failure at 2:28 a.m., police narrowed the crime down to a precise 41-minute window. AI analysis of the signal drop even suggested she was likely taken directly from bed, or just after waking up. So the doorbell camera was disconnected. Initially, the sheriff said there was no video footage because Nancy didn't have a cloud subscription. In the old days, that would be the end of it. But the FBI and Google engineers performed something called digital archaeology. Here's how it works. When a smart camera sees motion, it instantly uploads packets of data to the server to send you an alert on your phone. Even if you don't pay for recording, those data packets exist for a split second in the server's temporary memory, what they call electronic junk. Analysts wrote code to scan Google's massive data centers for junk files associated with Nancy's device ID. They found them. They recovered 44 seconds of video from 2:12 a.m. The system had deleted it, but digital archaeology brought it back. Okay, they found the data files, but they were corrupted and fragmented. It was like trying to read a shredded book. To fix this, they used deep learning interpolation. Imagine you have a picture with missing pixels. A neural network, a type of AI, looks at the pixels around the hole and mathematically predicts what should be there, based on millions of other images. The AI reconstructed the video frame by frame. It revealed an armed individual in a ski mask, using desert plants to hide from the lens. This is the power of AI. It took nothing and turned it into the biggest lead of the case. The video gave us a suspect, but they were wearing a full face mask. Facial recognition was useless, so investigators looked at the body instead. They used gait recognition. Science tells us that your walk is as unique as your fingerprint. It's a mix of your bone structure, muscle density, and neurology. The AI extracted a silhouette of the suspect and built a 3D model of their walking style. It measured things like stride frequency, how fast they step, joint articulation, the specific angle of their knees and hips, arm swing ratio, how far their arms move relative to their body. The goal? To mine historical footage from the neighborhood and find someone walking the exact same way without a mask in the days before the crime. You can hide your face, but you can't hide your walk. Even with the mask, there was one part of the face visible: the eyes. Teresa Guthrie, a former White House CIO, reminded us that the eyes don't lie. AI image enhancement sharpened the video until they could see the pixels inside the mask's eye holes. They measured the interpupillary distance, that's the exact measurement between your pupils, and the curvature of the brow bone. They ran these measurements against the FBI's Next Generation Identification (NGI) database. While it couldn't give a 100% name match like a fingerprint, it allowed them to filter out millions of people. If your eyes were too far apart or too close together compared to the video, you were cleared. It turned a list of millions of suspects into a much shorter list. We've talked about specific technologies, now let's talk about the network. This investigation used an ecosystem of surveillance. It relied on three main platforms. 1. Fusus. This connects private security cameras to the police. It allows officers to search video for objects, like male with black backpack, so they don't have to watch hours of empty footage. 2. Flock safety. These are license plate readers. Over 200 cameras scan the area. The AI didn't just look for plates, it looked for anomalies, cars that never visited the neighborhood before that specific night. 3. Coplink. This system let 19 different police departments share their data instantly. It's a massive data dragnet, where private cameras and public scanners work together. Sometimes, the breakthrough isn't biometric, it's commercial. The AI analyzed the suspect's backpack and identified it as a specific 25-liter Ozark trail hiker pack. Why does that matter? Ozark Trail is a Walmart-exclusive brand. So investigators queried Walmart's database. They looked for anyone who bought that bag in Tucson in the last 6 months, and then cross-referenced those buyers with cell phone pings near the crime scene. They were looking for a retail digital match. The AI also noticed something strange about the weapon. The suspect had a small pistol, but it was in a holster meant for a large revolver. This mismatch told the FBI profilers that despite the technical skills to cut the camera, the suspect was likely an amateur with weapons, effectively profiling the psychology of the attacker. We have to be honest. AI isn't just helping the police, it's also hurting the investigation. This case highlighted the danger of adverse AI. Savannah Guthrie asked for proof of life, but in 2026, you can't just hold up a newspaper. AI can fake a voice or a face in seconds. Investigators now have to use digital fingerprinting to scan incoming ransom videos for pixel glitches to ensure they aren't deepfakes. We actually saw a scammer, Derek Kalela, try to fake a ransom demand using AI text generation. Luckily, AI defense tools traced his IP address and caught him in Los Angeles. It's a constant battle between AI detection and AI deception. Technology moves fast, but bureaucracy moves slow. This case exposed a major friction between local police and the feds. Sheriff Chris Nanos actually resisted federal help at the beginning. He wanted to use a private lab for DNA testing, while the FBI wanted to use their high-tech lab in Quantico. This delay matters. The breakthrough in this case, recovering that deleted Google video, only happened because the FBI stepped in. It proves that in modern crimes, you need the massive computing power that only federal agencies and big tech companies can provide. So what have we learned from the Nancy Guthrie investigation? We learned that we have entered the era of the algorithmic dragnet. Whether it's the heartbeat of a pacemaker, the purchase of a backpack, or the way you walk down the street, everything leaves digital exhaust. The suspect thought they were invisible because they wore a mask and cut the camera. They were wrong. The digital archaeologist and the behavioral analyst are the new detectives. And as this case shows, in a world of sensors, the truth is always recorded. We just have to know how to find it. Thank you for watching. We sincerely hope she is back soon. And safely. Please consider becoming a member of the AI with Arun Show. And please like, share, and subscribe to the channel. We will be back soon.